As you can see, we're doing a related rates problem here. Air being pumped into a spherical balloon so its volume increases at a rate of 100 centimeters squared per second. We want to know how fast the radius of the balloon increases when the diameter is 50 centimeters. So, as usual, we want to start out by identifying what we know and what we don't know. We're given the rate the volume of the balloon is increasing, that being 100 centimeters squared per second. Now that's a rate that should say to you, oh, derivative. So the derivative of volume with respect to time, dv dt, is 100. I won't bother with units, we've already identified them. We are trying to find now the rate, so another derivative, of which the radius of the balloon is increasing when the diameter is 50 centimeters. Interpreting this tells us that we are trying to find, so what is dr dt, the change of radius with respect to time, when the diameter equals 50, or of course what we really want, the radius is equal to 25. Because this is a related rates problem, we need some sort of equation or formula that relates these two variables we're working with, namely the volume v with the radius r. Because we're dealing with a spherical balloon here, we're going to deal with the volume of a sphere formula, which you all know as v equals 4/3 pi r cubed. Of course, we don't really want to deal with just v and r here. We really want to deal with dv dt and dr dt, so we're going to need a derivative. We're going to need to explicitly differentiate this equation with respect to t. So we're going to end up with a dv dt and a dr dt in our formula when we're done. Of course, we should all know how to do this at this point, but if you have some questions about it, come and ask me. Send me a message in the comments. So this is what we should get after differentiation. Now we're ready to pretty much finish the problem. We know all of the values for this. We know our R has got to be the 25 centimeters. We know dv dt is 100 centimeters squared, 100 centimeters cubed per second. So we need to go ahead and solve for dr dt. And there we have it. Again, leave a comment if you need help with that. That's solving for drdt, putting in the values we know, the 100 for ddt and 25 for r, and leaving everything in terms of pi. We're going to get a not very pretty but correct answer of 1 over 25 pi centimeters